Welcome to Online Math for All. Here we have a problem on complex number. We have an equation a plus bi is equal to 23 negative I over 2 positive 3i. We have to find the value of a and b. Okay, whenever we solve this kind of problems on complex numbers, so the complex number here we have on the right side has to be in standard form. What is the standard form of a complex number? That's nothing but a plus bi. That is, we must have real part and imaginary part separately. Okay, so to get this complex number 23 minus I by 2 plus 3i in standard form, consider the complex number you have in denominator, that is 2 plus 3i. So now what we need to do is we have to take the conjugate of this 2 plus 3i. So the conjugate of 2 plus 3i is 2 minus 3i. Whenever you want to get a conjugate of a complex number, you just change the sign of the imaginary part, that is I part. So here the I part is having positive, 3i is positive here. So to get the conjugate of this complex number, just have to change the positive 3i as negative 3i. Okay, once you get the conjugate of the complex number what we have in denominator, you multiply both numerator and denominator of this complex number by the conjugate of 2 plus 3i. Okay, let's do it in the next step. So a plus bi is equal to 23 minus I times the conjugate of 2 plus 3i, which is 2 minus 3i, and the denominator also to be multiplied by the same conjugate, that is 2 plus 3i, already it's there, it has to be multiplied by its conjugate 2 minus 3i. So we are doing this work to get this complex number in standard form. Okay, now we have to do the regular multiplication, that is we have to multiply these two binomials. Okay, so we can use FOIL method, that is 23 times 2 will be 46, 23 times negative 3i will be negative 69i, negative I times 2 will be negative 2i, negative I times negative 3i, negative times negative will become positive, I times 3i will become 3i square. Okay, in denominator we have 2 positive 3i, 2 negative 3i. So it is in the form of a positive b times a negative b. So in algebra, it's one of the basic identities. We know that a positive b times a negative b is equal to a square negative b square. So when we compare this 2 positive 3i to negative 3i to a positive b and a negative b, we have 2 for a and we have 3i for b. So a square negative b square means what we need to do is, for a square we have 2 square and for b square we have 3i the whole square. In case you don't remember this identity, what do we have to do? It's very simple. We can just do this multiplication in a regular way. That is 2 times 2 is 4, 2 times 3 is negative 6i. In this way we can multiply these two binomials. But if you remember identity, easily we can do the multiplication. Okay, in the next step what we can do is a positive bi is equal to, we can simplify the terms in numerator. So 46 negative 69i, negative 2i, they are like terms, so we can combine them. We get negative 71i, positive 3 times the value of I square is negative 1. So in complex number always we have to remember the value of I square is negative 1. So wherever you have I square, you can substitute negative 1 for it. So here we have 3i square, so 3 times instead of I square we can substitute negative 1 divided by the value of 2 square is 4, negative 3i whole square means it can be written as 3 square then I square. Okay, so we have a positive bi is equal to 46 negative 71i, positive times negative will become negative 3 divided by 4 negative, the value of 3 square is 9 and the value of I square is negative 1. Okay, a positive bi is equal to, you can combine 46 and negative 3, it will be 43 negative 71i divided by 4 negative times negative will become positive 9. So a positive bi is equal to 43 negative 71i divided by 13. Okay, now 13 is a common denominator for 43 and negative 71i. So to write this complex number in standard form, we can take this 13 denominator separately for 43 and separately for 71. So when we do it, so we'll be getting a positive bi is equal to 43 over 13 negative 71 over 13 I. So now this complex number is in standard form because we have real part and imaginary part separately. So here on the left side also we have real part and imaginary part separately. So whenever two complex numbers are equal, we can equate the real part and imaginary part. So the real part on the left side is a, on the right side the real part is 43 over 13. And imaginary part is nothing but the coefficient of I. On the left side we have a positive bi. So here the imaginary part is the coefficient of I, which is b. On the right side the imaginary part is negative 71 over 13, which is the coefficient of I. So now we got the values of a and b. The value of a is 43 over 13 and the value of b is negative 71 over 13. I hope this problem can be understood by everyone. If you like this video, please subscribe our channel. Thank you.